If you're a student interested in neuroimaging, or maybe you're just interested in general, chances are that you don't have your own lab yet, or maybe you're in the process of building your lab, but it's just very hard and difficult. And, it costs money, and not only money, but it costs expertise, it costs permission, etc. Now, the good news is that many universities or scholars are making their raw data available. In our case, neuroimaging data, let's say EEG data, even MEG data I've seen. And that is amazing news for us. As we talked before, for example, you might be interested in just poking around some raw EEG data and see, how it works, what you can analyze, what you can come up with. Maybe you're just exploring to see whether EEG is even something you'd be interested in. Or, as we also talked in the past, maybe you're interested in neural networks and you're aspiring computational neuroscientist, but you don't have data. And if you're a computational neuroscientist or an aspiring one, you also know that you're definitely dependent on the data that people from the lab could potentially make available. Again, the good news is that in today's scholar society, a lot of these scholars are making their data available. I myself have actually pondered upon making it available because I know that some people have even asked me, especially when they saw my book, because my book is this sort of hand book or guidebook, if you will, if you were to use Emotive Epoch Neuro Headset series together with EEG Lab open source environment as your software. So today I want to show you some samples of this free data that is available. One of them is through UCSD, San Diego, University of San Diego, and then also one from Harvard University. And these are just two, by the way, that data set that I want to show you. But if you're interested in other type of data set, definitely I encourage you to search for it, and they are basically available. So let me share my screen, and I want to show you this first one. This one is the one that is from UCSD, University of California, San Diego. And I will put up the link in the description below so you can actually see it. But just to show you, this is an EEG/ERP data. And if ERP, if you guys remember, I did a video on it, I think, I don't know, a couple of years ago. And that is also very interesting. Most of the data you may want to gather is ERP. By the way, there is an ERP conference that is coming up. If I can find the link, I'll also share that with you. I don't remember who's holding it, but it's interesting as well. And then in this case, they're saying, hey, this is updated in 2020, so you kind of know what you're dealing with. And then they go along and talk about what this data is. So then basically the origin or the distribution of the data, you want to know before you start even testing with any of our data, you want to know why that data was collected, how many there were, and etc., because these would be good variables that you would have in your research analysis. Otherwise, if you just have a bunch of raw data, you won't be able to make some meaningful analysis out of it. So these are sort of the demographics data that you would need. In this case, it's good to know that this was a 32 channel data from 32 channel sensors. There were 14 subjects for this, 7 males, 7 females, and they were acquired they used the NeuroScan software. Subjects were performing a go, no-go categorization task and a go-go recognition task on natural photographs presented very briefly, 20 milliseconds. And this is also interesting because they're actually looking, this is a data, for example, for the subjects looking at data. And if you remember when we talked about the convolutional neural networks, the pattern recognition, the image recognition was also part of that neural networks that we talked about. And these are pretty interesting to explore because you may be able to sort of also even use convolutional neural networks with this type of data to see whether you can, for example, figure out some pattern recognition, et cetera, within this data set. Each subject responded to a total of 2,500 trials, et cetera. And then they talk about the OpenNeuro and NEMAR databases. OpenNeuro is a well-known data archive created by Paul Drake and his team at Stanford University. OpenNeuro is a free and open platform that allows researchers to upload and share neuroimaging data. That's good for me, because I was actually thinking, where and how should I upload my data? I guess this would be a good way for me to also explore to see whether I should and could submit it. Submitted data sets can then be analyzed by anyone who logs in. OpenNeuro has been designated by NIMH as a repository for data collected from Brain Initiative projects. That's also very interesting, because it's kind of become centralized in terms of having access to all these data sets. And also, as well as other types of neuroimaging data. However, a date workflow only exists for fMRI. Oh, so it's only fMRI data. Okay, that's cool. Anyway, so then they go on and they talk about other data available on the internet, data sets in MATLAB from the EEG lab tutorial. This is the software that I use, or the open source software that I used. And also this was developed by UCSD, by the way. And the book that I wrote uses this software as well, explaining it step by step, how to use the software, if you use emotive epoch neural headset, the 14-channel neural headset that is commercially available that I used in my own thesis. And then here they're talking about different data sets that they have. Other EEG data sets or data set known to us are, and again, they talk about additional data sets here. So I think this is very, very cool for those of you who are students who maybe don't have your data yet, to actually use this type of data sets. So I'll definitely put the link down below so you can check it out. Another one that I wanted to talk about is from Professor Haydari at the at the Harvard University. And he also talks about EEG open data and open data sets in EEG. This is a list of openly available EEG. It also has MEG, by the way, if you're interested in that. Data sets and research listed here should all be openly accessible for research purposes, requiring at most, so it's just registration is needed. So all you need to do is just register, and it's free registration. Basically, as always, you just give your email. Be sure to check the license and a usage agreement for any data sets you access. I think this is very important, because if you are to be using anything free, especially data sets, it's really good that I feel like the very good practice is that first and foremost, you give credit to the person who actually collected the data, because credit needs to be given. I think a lot of people, not so much in the scholarly world, but in sort of other world in internet, they just take stuff from each other and they just post it. But I think it's a great practice to give credit. I always do. So I highly recommend, especially if you're a student, to kind of get that practice on and definitely give credit. And also just to not get into trouble, definitely look at license as usage agreement. Most of the days data sets were available for free. They actually do let you use the data for free if it's for research purposes. But let's say that if you want to use it for commercial basis purposes, however the commercial usage may be, then most of the time it's not under that license. So if you're just interested in knowing how to work with the data and just doing your own experiment and maybe even talk about what you did, great. But probably if you want to publish the paper and or use it for commercialized usage, that probably there are some, I'm pretty sure there are some limitations there. So be careful about that. To contribute a new link to data source or open instrument. Okay, so table of comments. So data formats, they talk about the data formats. That's very important because any data set that you want to use, you want to make sure that the data formats that you are accessing is actually something that you can work with. And if it's something that you can't, you might have to reprogram. For example, if you're writing codes for your neural networks experiment, then you may have to kind of adjust that because any type of data sets needs to be read by the codes that you're writing. And so if they are not corresponding, then you will get a lot of error messages. So that is part of it as well. You need to sort of polish the data when you access a database in actually any form or shape. Standardized data formats for neurophysiological data includes, so they talk about the formats that are data formats that are standardized. They also talk about the repository. There are several repository journals and search engines that can be checked and search for relevant databases. Yeah, OpenNeuro is one of them. That's awesome. And then etc. So you can look more into it. General purposes data repository, data journals, data search engines for EEG data, openly available EEG data sets and large-scale projects with EEG data. So that's really cool. Google has a data set search tool that can be used. That is really cool. Let's actually look at that. So this is the data set search. So let me just search for EEG data signals, unique identifier, simulated EEG data generator, EEG data from hands movements, EEG alpha waves data sets. Let's look at alpha wave. That's really cool. That's brilliant, actually. This is the first time I'm seeing this. That's really cool for me too. I'll put this link in below as well. And then further, he talks about EEG base, etc. Anyway, so there's a lot of great information. Oh yeah, and here's the MEG data. If you're interested in MEG, you could definitely do that as well. So definitely, guys, check this out. Dr. Haydery at Harvard, as well as the UCSD's pages. And I highly recommend that if you want to just poke around, let's say that you are either you're in neuroimaging for a long time, or maybe you're just sort of exploring at this point. It definitely is so much easier than it was in the past, because in the past you had to have your own lab. It costs money. There's just so much paperwork you had to fill in. My IRA, for example, to get permission from the university to run my subjects, I had 57 subjects in total. It took about 3 to 5 months, I think, if I remember correctly. So there's just a lot of paperwork. You have to get permission, and you have to run each session. For me, took 2 to 3 hours. So that times 57. And I had 3 data sets for each of the subjects. So it was 100 something data sets. So it really adds up, and it's extremely time consuming, as well as, of course, financially. So definitely take advantage of this. You might become a little bit frustrated if you, for example, try to get access to these databases, and maybe you have to like polish the data set. So that might be a little bit consuming. But honestly, guys, in comparison to, for you to polish data set and or find a data set that you're really interested in, compared to running your experiment, creating your lab, or applying to a lab, or running your experiments, I mean, the comparison is just nothing, both when it comes to financial pressure as well as time pressure, but also just like convenience, because for me, I had to drive like many miles, 20, 30 miles to get to the university where I had, I wanted to run those participants or those subjects. who were actually university subjects. So all in all, this is extremely convenient, extremely important, and extremely easy. So take advantage of that. Don't get too hung up on, oh, I can't find the right set of database, data formats, or sucks, or missing data here and there. Honestly, in comparison to what you have to go through in order to create your own lab, this is like nothing. So just go with it. And if you feel like there's the data set that maybe it's not as good, just go on to the next one. But don't quit so fast, because I've seen it with some students that in computational neuroscience that, a data set was not perfect because they had some missing data. There's always missing data. And they were just frustrated. Oh, this shit doesn't work. I spent so much time writing this code, but like do your own due diligence before you even embark on writing your code. Look at the data and see what's available, what you can do, and whether you're even interested in that or not, and then go on and do it. So there are a lot of best practices that is being communicated about how to actually set your analysis if you're just, let's say, working with other people's data. Let's say you're a computational neuroscientist, not necessarily an experimental neuroscientist, and you're just working with other people's data. So there are a lot of best practices. So don't be that guy to just complain. This is like amazing time. I think that it's brilliant that we have access to so much data. And now, let's say by just coding, let's say writing a few codes in Python, most of which is also readily available, and you can just sort of pick and choose from other people's codes. It's just amazing. I mean, I really hope that you can make this and go through this and make this happen. And actually, who knows, you might be able to write your own paper even without, spending a lot of time or money. All right, guys. So I hope this was useful. I'll see you guys next time. Bye.